Vanishing Stars and the Hunt for Extraterrestrial Objects.
Thank you so much. Thank you so much for inviting me here. It's a really great honor to be here to talk about my research. So I'm going to tell you about how we can search for extraterrestrial artifacts, just like was just introduced. Let's first start with an anecdote, and we can go back 70 years. That's quite a long time. So in July 1952, this was a very special month because what happened was that this particular month, many people saw UFOs, much more than normally. And it started with that air traffic controllers at Washington National Airport saw multiple weird objects on their radar. These objects were moving very fast, with strange movements, and this was seen on multiple radars at the same time. At the same airport, also pilots and stewardesses saw weird things in the sky. Now, this happened not only once, but it happened over 2 consecutive weekends, the 19th to 20th of July and the 26th to 27th of July, where it was a peak in seeing these weird objects. And if you just take a look at the numbers, while in the early 1950s, one had 15 UFO sightings per month registered, in July 1952, there were 536 sightings. This caused lots of news over the whole country. And there was several thousands of newspapers that were printing that were sources over the capital. It's very often referred to as the 1952 UFO flyover or UFO carousel. It was so serious that even the US Air Force had to hold a press conference. And that was the largest press conference since the announcement of the end of the Second World War. And here you see General Samford on the picture, where he's explaining that what was seen there wasn't actually anything to worry about. What the people, what the radar controllers had seen were some kind of weather disturbances that caused these weird objects on the radar. And what the stewardesses and pilots had seen, that was just misidentified aerial phenomena. And even pilots that time had actually been sent out to hunt for these objects. And the final thing that Samford said was that there were no threat to any national security. And that was the end of the story. So in this talk, I would like to discuss whether we can search for UFOs or extraterrestrial objects. And this, of course, ties into some of the questions that many of us are really wondering about. Are we alone in the universe? Because we don't know of any other civilization except of our own. And these are very fundamental questions that people have been wondering for as long as we can. For years and years and thousands of years, we have been wondering, are we alone here? So now let's see if there's any way how we can actually figure this out. And are these UFOs anything we should worry about, think about, or hypothesize as extraterrestrial probes? And how can we actually relate these phenomena to searches for vanishing stars? I'll let you stay with that thought for a little while until we come back there. Let's first have a look at the prospects of life. And we can just take a look at our own galaxy, our own Milky Way, that looks like on this picture, more or less. We have approximately 200 to 300 billions of stars in the Milky Way. That is quite a lot. We only know, of course, of our Earth as having any sort of life at this very moment. There are billions of planets that are similar in size to the Earth and that are orbiting within the habitable zone of their star, where you can have liquid water and prospects of life. Then basic building blocks of life, like amino acids and the basic building blocks of the DNA molecules have been found on meteorites, on asteroids. So we know that this chemistry is not entirely unique to the Earth. So with all these basics in place, one might start wondering how frequent and how common is life out there. And we hope, of course, that with this new JWST, the James Webb Telescope, we will, of course, start learning or seeing some of these signatures of life rather sooner than later. Unfortunately, so far, no life has been found outside the Earth, not even a microbe. But we can hope, and I personally think that there are excellent, really excellent opportunities for life and advanced civilizations to exist in our Milky Way. Let's see if you will agree with me later. Since the 1960s, astronomers have been looking for intelligent life with big radio telescope, like the Green Bank Observatory or the ATA array, the Allen Telescope Array. And one has surveyed more or less 300,000 stars. So did we find any candidate after 60 years of searches? I guess most of you know that so far not. And if you have seen this movie, Contact, how many of you remember the movie Contact? Okay, good, many of you have seen it. It's a very beautiful movie. So you have Dr. Ellie Arroway, she's searching for radio signals, and she's searching, and finally one day, she gets contact. Well, unfortunately, in reality, she's still waiting for a signal. Another way of searching for life is to look for lasers. Because, let's face it, we as Earthlings have already moved on to using lasers in our communication when we have our satellites. Lasers are very good for communicating, have a high bandwidth. It's possible to keep it very private. And people and astronomers are also searching for laser signals, therefore. Unfortunately, so far, nothing has been found, although here, much less effort has been invested into searching for lasers than if you compare with the radio searches that are going on for too long. Another way how one can actually look for these, for civilizations, is by looking for something that is really weird, a so-called anomaly, something that you don't really understand, it looks strange and you can't explain it. So 2016, I'm not sure everyone here remember 2016. I think some of you are a little younger than that. You don't remember. So 2016, there was a very interesting star that was discovered that had a weird way of changing its brightness. And it was getting like fading or dimming very slowly. And then some astronomers thought maybe this dimming comes from that you have some kind of very big artificial structure that sometimes comes in front of the star and makes it, of course, appear dimmer. Let's say you have some alien civilization that has built this huge structure around the star. And they tried to investigate the star that was called Tabby star. Unfortunately, they couldn't find any other signs or they couldn't find any signs of any intelligent civilization. But this idea with looking for these so-called weird objects or anomalies keeps on happening. There is the famous object Oumuamua that many of you have seen about in the news, where there's a discussion, is this a natural object or could it be a spaceship, a defunct spaceship? Because it has a weird movement and it has a weird non-gravitational acceleration, and some astronomers believe that this might be a spaceship. Another question that has been bugging me for a long time that is also related to anomalies is whether a star can just vanish. And here we have a little poem by Hausmann that some of you might know. Stars, I have seen them fall, but when they drop and die, no star is lost at all from all the star-sown sky. So let's think for a moment how we can actually interpret this. Stars, when they are very massive, when they die, they usually explode in a very bright supernova. When they are lighter, they can take billions of years to fade into a white dwarf. But can a star that is there just one day vanish and you don't see it again? And that is a question. And how could we relate that, for example, to searches for extraterrestrial civilizations? And this is something I started with in my final year as a PhD student, to search for vanishing objects in an attempt to unite searches for weird anomalies that could be maybe natural, maybe not natural, and with these searches for extraterrestrial intelligence. And the idea was, of course, that maybe there is some really advanced civilization out there that could defy what we know about stellar evolution and just make a star vanish, and I would be very happy. One way of, there are also some theories that astronomers have proposed that in some cases, maybe some massive stars are going to collapse directly into a black hole, and they're so-called failed supernova. I don't know if there's failed supernova or failed supernova theories. We will figure that out. Another thing that maybe if you do these searches, you could expect to find is that some galaxy cores where you have lots of accretion of gas and that emit a lot of light. In this galaxy core, we call them quasars, these supermassive black holes that are accreting all this gas that emits all these super strong lights. And these quasars sometimes can also vary in their brightness. So maybe if you look for these vanishing objects, you will find such things too, which can be fun. Now, that was the main question I was wondering, and this is how we started working with the vanishing and appearing sources during a Century of Observations project. We were taking images from the 1950s, early 1950s, and comparing them to images of the sky as it looks today, hoping to find a vanishing star. Or even better, imagine an entire galaxy that vanishes. I would be very excited to see a complete galaxy that just fades. So now these old images, they were not taken with the same technology as we have today. They were taken on these old glass plates that had photographic emulsions, and these plates, one later digitized so that astronomers today can look at how the sky looked in the early 1950s. So we did these searches hoping to find Darth Vader. Unfortunately, we didn't find him yet, but we found some quite interesting images. And what you see here is a star in the upper left corner. Can you see it? Or something that looks like a star. It's not a star, but it looks like a star. And then you look at other images, like for 30 years later, 50 years later, 60 years later, and you never see that thing again. And it gets even more interesting. What we noticed is that we found hundreds and actually later thousands of these, where you only saw them in one image, but not half an hour earlier and not half an hour later. Something that flashed up briefly and later vanished. Journalists love calling them vanishing stars, but I prefer to call them transients. Me and the journalists don't really agree with each other here. So this is how one can actually run and actually participate in these searches. So what we did is that we created a little, so-called citizen science project, which means that every one of you could go to participate, and you could join the search for vanishing stars. And what you do here, you see on the left image, an image from the early 1950s, and on the right image, you see an image of the sky as it looks today. And you just have to go there, and you have to compare the images, and you can play around, you can rotate them, you can expand them, make them smaller, rotate them, you cannot delete them. But then you can also select between 5 classes that you can see there to let us know, has any object vanished? Because we had 150,000 of initial candidates, and some of them were vanishing, or some of them were kind of appeared like they were vanishing, and other things were just a lot of errors in the images, and we needed help to look them through. In a previous work, I had looked through 24,000 objects by myself, one by one. Lots of chocolate, lots of tea, and much worse ice after 3 months. But this is a page that everyone can participate in, and you can go there and just search for the aliens. We have been working a lot with school classes, amateur astronomy societies, and in particularly in Africa, we're also in Spain. So we have many, hundreds of kids from all ages, and also adult amateurs who have helped to participate, who have helped these searches for vanishing stars and helped us to go through the entire data set. And so the students are here on a picture. You see these pictures are from Algeria, where the students are searching for these objects. And here you see the teachers and the leaders and the scientists who have helped to coordinate this very important effort in Africa. So this is how it looked like with the classification. We tried to have a look at, during 2 years, at the number of candidates that we could find, the total number, and just the number of detected transients that we could see. And you can see that the project was first not very interesting to people, but then they discovered that it was fun, and we started getting lots of candidates coming in. So what was the most interesting thing that we found here? Because, as I told you, we haven't found Darth Vader yet, but we found something else. One day we found a very peculiar image where you see 9 stars in one image, and you see nothing else half an hour later. And you start wondering, what is this? Let us have a look at it. So if you look at the green circles, the green, you will see 9 stars on the left side. They are there in a small part of the image on the 12th of April, 1950. Now, if you have a look at the right side of the image, that is already from the 1980s. So the 12th of April is on the left side, and the 80s is on the right side. And what happens there is that they vanish. They appear and vanish within half an hour, and not only one, 9 of them. That is a very confusing thing. So we started wondering, could there be some kind of known astronomical phenomenon that could create this effect that we see? And we were wondering, could some supernova kind of create this? Well, you would need 9 supernovas, and supernovas are pretty rare, and they're not going to be in that little part of the sky, all of 9 of them, unless Darth is back. We were also wondering if there could be some asteroids or meteor, but again, the problem is that these old photographic images, when they were looking at the sky and taking images, they needed maybe 50 minutes of exposing the image, 50 minutes, so anything that would move that fast would leave a streak. But we found 9 stars, which means that this looks stationary. We were considering other kind of astrophysical events, and no matter what we looked at, one effect or another, nothing could explain 9 objects appearing and vanishing within this half an hour. We started wondering about instrumental issues. We were wondering maybe some kind of high energy particles from outer space. Because sometimes high energy particles from outer space in modern imagery, where you have very, very, very sensitive instrumentation that can catch anything that just happens on the sky. Sometimes in these super, super sensitive images, you also have high energy particles disturbing. However, these photographic plates from the early 1950s are very unsensitive and even less sensitive than your eye. Another thought that we were wondering is, so double exposures. In the times when photography was done with these emulsions, sometimes people could pull, let's say, tricks in the sense that they could expose 2 images, different images, and put them on top of each other, and you can produce, like you see here, a fake ghost image. It's not a real ghost image, that's a fake one, and it's the art of double exposure techniques. We also couldn't find any signs of that explaining the 9 stars. We were wondering that maybe the photographic plates had some kind of different sensitivity or so. No, we couldn't explain that either. We tried different kind of instrumental issues. Then we thought maybe there's some kind of dirt or defects or some kind of problems with the emulsion, something that happens with the photographic plate itself. The problem was that usually when you have these defects, they have all kind of weird shapes, but there's no reason why they all would look like stars, and like perfect stars, all 9 of them, or at least. So we wrote a paper and we sent it to a prominent journal, and we went through explanation one by one. We had 2 referees. One said that we should look at one thing, but the other referee wouldn't let the paper pass through too easily and asked us, "This is the year of COVID," he or she wrote. "Are you sure that it's not just that somebody sneezed on the plates?" And we had to make different tests to see how, if someone sneezes on the plates, would look, and if that matched what we saw. I can say it doesn't seem like anyone sneezed on the plates. So then we thought about another hypothesis. What if there were some secret atomic bomb tests? Maybe this secret atomic bomb test could produce some kind of nuclear fallout, like these certain isotopes. And if that happens, maybe they will also like dirt down our photographic plates. Because as it happens is that in the late 40s, when people were trying out the atomic bombs, and there was the famous Trinity test, some Kodak plates got a little contaminated all over the country. So all over the country, the X-ray images of Kodak had issues with, they by mistake detected these atomic bomb tests that they shouldn't have seen. However, so what did we do? We remember 12th of April 1950. So we went to the official catalogs of the atomic bomb tests and looked, were there any atomic bombs tests listed in that year? And we found out that no, there were no official atomic bomb tests in the United States in the early 1950s. And since I am no conspiracy theorist, I have to give up on that beautiful hypothesis. So what is then left for us? Well, we thought about, how about extraterrestrial satellites or some kind of objects or artifacts that extraterrestrial civilization could leave there. For example, you could produce something that looks like a star by having a very brief flash. especially if the object is in particularly convenient orbits, then you can have, let's say, if you have a very flat artificial object that reflects sunlight, you can produce this short flash and then it will look like a star. Let's say you have something that looks like space trash. Then maybe you could produce this type of flashes. Or if you actually have a UFO that emits some kind of blinks. It blinks a little and then it stops blinking. Or you have many UFOs that blinks a little bit and then they stop blinking. The problem is, again, in the early 1950s, there was nothing human. So 1950, 12th of April, we were not aware of any human satellites. Because the first satellite, Sputnik 1, was launched in 1957. So this is an idea that came to mind. Now, if we just play with the thought, could ET have sent something to our solar system? Well, we know from Voyager 1, Voyager 2, and the Pioneer probes that we humans are technically capable of sending a probe to another stellar system that is nearby. Okay, it might take you 80,000 years, but even if you don't think about living beings, but if you imagine that the probe that you send or the object that you send is some kind of self-replicating, self-repairing object that takes care of itself, and as it flies there, maybe it will be transmitting data to us. Maybe 100,000 years isn't that long. So it's not impossible. And this is where we can start thinking about the discussion that we have all seen in the media in the last year about UFOs. So in the early 1950s, they weren't called UFOs. They were called flying saucers. Then somebody thought that it sounded more serious by calling them unidentified flying objects. Now, in the last 5 years, they think that it will sound even more serious by calling them unidentified anomalous phenomena. But we still talk about flying saucers for most of the cases. Except for sometimes when it's also, UAPs also include Russian missiles. So we saw the US Navy released several videos that one can discuss a lot about of so-called UFOs, when pilots have seen some kind of UFO. And in this discussion in 2021, we suddenly also included the famous Oumuamua object that I showed earlier. And the US Congress arranged a report that's where they examined various kind of UFO cases. And last year, in July 2023, I don't know how many of you have seen the news that there was a whistleblower that testified under oath in the US Congress saying that he had interviewed 40 people who were working on programs where they had retrieved crashed UFOs from non-human intelligence, and they have been working with these crashed UFOs. So this became very big news, and many of you might have seen. So before we jump to any conclusions, what does actually science say about UFOs? And what would a random scientist say? Are there any UFOs?
I'm a scientist. I have some opinions, and I would like to discuss briefly some opinions about the evidence. And so I'd like to do that by addressing the aliens themselves in a song that I wrote, which goes like this. What'll I do when I am seeing you, but you're not there? What'll I do? What'll I do with my belief in you? It's not a fact, isn't that true? What'll I do with fuzzy photographs they're problematic too. How can I know it's me that you pursue? I have no clue. What'll I do?
This is an excellent summary. So, this is where science stands on UAPs. There are many ways to also explain why there is not so much that has been done in science, and that is because there is a very strong stigma. Many scientists have felt scared to touch the topic for decades because of this very strong stigma. And if you have strong stigma, there's little funding going into this research. And if you have little funding, it's difficult to get results. And if you have no results, then nobody's going to believe that it's worth to do this research. So it goes on as an evil circle that is very difficult to break. But in 2023, NASA actually summoned a panel of 16 experts from different fields in order to look at the evidence that could exist there and to say whether it's worthwhile to study UFOs. Again, UAPs or UFOs, call them or flying saucers, you can call them what you prefer. They concluded that there is a very strong need of a centralized reporting system. And there is a need to remove the stigma around the UFO topic that has been blocking the understanding for so long time. Further, they have actually now appointed a UAP research director. And during this meeting, the DoD actually admitted to that they have some very interesting photographs or video footage where you can see some unidentified objects, mainly metallic orbs, moving weirdly in these images. And they had seen thousands of them. So I think that was a quite interesting news coming out of them. So let's see. This is where one actually can start wondering, should we do searches for these objects? Should we maybe then start taking it seriously and actually look for UFOs directly? And maybe we can somehow tie it into the vanishing star research. So remember one thing that is very neat about the photographic plates. They were from the early 1950s, when there was nothing human in the sky. Today, you have lots of satellites. You have thousands and thousands of satellites, and you have millions of pieces of space debris that are blinking there in the sky. And these million pieces of space debris that are blinking all the time in the sky are releasing this kind of transients or are causing this kind of transients on imagery that is not so fun to deal with. But when you go to the early 1950s, if you look for something that looks like a human satellite, maybe what you find is an alien spaceship. So what could we expect? Well, one thing you can expect when you look for these ET probes, either flashing, so kind of those that have their intrinsic light or that are reflecting sunlight, is maybe you see these multiple transients. Maybe if you have a rotating dish, you could see like triple flashes, but also you can find and search for several flashes along a line. That's maybe the easiest and most beautiful signature to look for. Of course, if you're slightly wondering, like, are my transients, if I look at multiple transients, are they real or are they some kind of plate effects? Versus the idea of that first they are, you have these transients, but also they are along a line, you're going to have a stronger support for alien spaceships if you find them along a line. Now, depending on the size of the image, you're going to have a different probability to see several objects along a line. Of course, if you find 25 of them in a small image, you are going to be fairly sure that it looks very real. If you find 3 of them along a line, you're not going to be as convinced. So statistically, you can play around with this and say, how many do I actually need along a line in an image of this size, if I have this and that many transients, and the line is this and this wide, or this and this big. So you can do your math statistics. Remember one thing that I didn't know when I was a student, and that is that courses in probability and statistics, they are really boring, but extremely important later when you do science, because that's where you have all your many of your techniques for answering questions. It's very important courses. Don't ever skip out on them. So we hypothesized what to look for, and then we one day decided to have a look. We took this data, these vanishing stars that we had found in the citizen science project, in the automated searches, because we have done many searches automatically. We had gone through billions of, like 1 billion of objects with automated searches. And we had found like thousands of these transients. And we started looking for those that were not only multiples, but aligned along a line. So here we found actually a neat example where you have a probability of a very small chance to get it. And you see here 6 transients where 4 of them align beautifully along a line. And we said, this looks interesting. So we got 2 top candidates that were statistically significant. The second one was even nicer. And this was our absolute top. You see 5 transients that are kind of along a stripe. 2 up there, 1 in the middle, and 2 below. You see the 5 stars, right? Okay, good. Now, remember this date. Just keep it in mind. We'll come back to it later. So this was, of course, a very exciting, these 2 were exciting findings. We didn't have very good luck when trying to publish it in a journal. We're still going to try to get it accepted. But we noticed that many journals are very scared of the UFO topic. It will not even go to peer review in most cases. So what are actually the implications of what we found? Well, there seemed to be something weird in the photographic plates in the early 1950s. And we need to know whether this is real or not. I'm going to put my bet on that it's real, otherwise I wouldn't be doing this research. And some of these multiple transients or multiple flashes that appear in and out of the images, they are also lying along a line. And we had 83 potential candidates, but only 2 really good ones, those that I showed you. Only 2 really good ones. And if it turns out that all of them are false, a good thing is that then we can set a limit for how rare are UFOs in the solar system. But we will see. We're still examining those. Now, more recently, with my colleague Enrique Solano, who works in Spain, in Madrid, and he's like computer guru, and he really knows how to extract efficiently images. He found this very beautiful example of 3 very bright stars, because all the other ones we had seen earlier were quite faint. These are 3 very bright stars that are seen in one image on the 19th of July 1952. I think people still don't remember the date. You can see it there. And then you don't see it again when you look, let's say, 40 years later. But you don't see it either half an hour earlier. It's again something that appears and vanishes within this half an hour or 50 minutes. We were wondering if there maybe was some kind of natural explanation. We tried different scenarios, and yeah, maybe you can explain it with gravitational lensing, or maybe it's something completely different. Maybe some new astrophysical phenomena. We have no clue, but we published a paper, and then a friend of mine pointed out a very fun thing that is a very fun coincidence that I recall probably is just a coincidence. The famous, our beautiful triple transient that we had already written a paper about happened exactly on the 19th of July 1952. You remember the case I showed you at the beginning with the UFOs over Washington? And when my friend said that, I said, how about these other cases that we tried to submit in the paper last year, the one with alignments? How about them? And we went back and looked at the table, and our top candidate was from the second weekend of the flyover. So now we had two coincidences that were very fun. Which, of course, again, two coincidences, you're always going to find someone, you're going to remember it. But what we will do now is to spend a little bit of time to see. We will have to do some tests with the photographic plates, taken from July 1952, and see if there might have been more multiple transients in that time period than other time period. Because we want to know if this is a coincidence or if there is actually something happening that left traces also in the photographic plates. Because that would be very cool. Then the General Samford would have to retract his statement about that it was uninteresting. But since we cannot solve this mystery just with these old plates, we have to find another way of doing the experiment. The problem is that when we work with these old plates and we find these multiple transients, they're always seen in one single image. But one single image, different things can happen to an image. It's not that you can really 100% say that this is real, this is an authentic observation, but how can we actually now, when we imagine that there is this kind of phenomena of multiple flashes appearing and vanishing fast, how can we search for the same thing in the sky as it looks today, when you have loads of satellites and space debris? So, we created a project called ExoProbe. Let me just double check one thing. That I'm in the correct, yes. So the ExoProbe has one single mission, and that's to look for multiple flashes and weird flashes, any kind of short-lived flashes, and like small objects that move on the sky, near the Earth, with the hope that we will find some signature from an extraterrestrial civilization. We want to find spaceships, artifacts, even if they leave a Coca-Cola there from 100,000 years ago. That's basically what we want to search for. So how does it work? Imagine if instead of waiting for a UFO to fly over your head and hoping to see that UFO, you could actually create some type of system that allows you to search the sky systematically for these UFOs and find them as they happen. But not only that, you would be able to validate that they are real, and you would be able to localize them where they are, but also you would be able to characterize them to see what is that flash that I see, what is causing this flash. And that is the idea we're working with. So today, there are several UFO projects, and most of these UFO projects that are done in science are trying to look at everything that moves in the sky. So let's say an airplane moves, they detect it. They see a rocket or a satellite or a three-winged duck, they detect everything, and they do this categorization with the help of artificial intelligence. And when you do that, that's great. And then what happens is that once they classify all the things that they can recognize on the sky, there's a little category that is left that are the so-called UFOs, what they cannot explain, and then they try to understand what they see there. That's how most UFO projects are being done today. However, it has some disadvantages, and that is that you need to recognize a lot of things and try to search for these remaining unexplainable objects. But what we want to do instead is not to do that big effort of categorizing things now. What we want to do is to search for an identifiable signature of an unidentifiable object. We want to search for an identifiable signature of an alien spaceship or an alien artifact that is in orbit around the Earth. And we also want to be outside the atmosphere, because if you're inside the atmosphere, you have all the airplanes and all the ducks. and all the geese. But if you're outside the atmosphere, well, you have the satellites that you need to handle, and you have the space debris, but you don't have all the other things. And also, it's easier to check if you actually have an ET artifact there if you're staying outside. So, what we now do is that we are imagining that one could build a network of telescopes, multiple telescopes, and each of these telescopes is going to be equipped with high-speed cameras that can quickly take images so that you can search for these fast flashes. And they should also have wide fields so that you can see a big chunk of the sky at the same time, and also be capable of characterize the flash so that you can learn something about its chemical composition, so that you know something about its origin or nature. And this is the idea. And all these telescopes should also be synchronized. The goal is to immediately you want to detect, you want to localize, you want to verify, and you want to reproduce any finding real time in principle. And you stay outside the atmosphere, and you can search up to maybe 150 million kilometers from the Earth, depending on how you select the distances. We will search within this range because we have certain limitations in how we can place the telescopes. But the beautiful thing about this is that you get rid of all the false positives. You get rid of all the wrong detections and misidentifications, and you can directly test the hypothesis. The hypothesis we want to test is, do we see flashes that look like flashes from aliens' spaceships? That is the hypothesis we want to work with. We don't want to work with this thing of looking for the object that cannot be explained, because that is not a hypothesis. We want to stay with the simple scientific methods to looking for flying saucers. Maybe I should call them flying saucers from now on, to be a bit clearer with what I want to look for. So how do you do this? The first step is, of course, to select the appropriate instrumentation. And for that, we have actually bought something called a plane wave delta rho half-meter telescope. And it's not only any half-meter telescope, it's a very good half-meter telescope that is capable of seeing things very accurately, and it's mounted on a so-called mount that is has a very good tracking of the sky. Also, we have a very nice camera there that is allowing you to take these images every second and even more frequently. And that also has a wide field. And when you do that, well, you have this very nice instrumentation that allows you to see all these fast flashes that could appear on the sky from an alien probe. It was quite a lot of work to select this instrumentation, I must say. A second thing you can do is, of course, that you want to have at least 2 telescopes. One is fun, of course, but if you want to really do this experiment, you want 2. Now, depending on how far you're placing the 2 telescopes from each other, you can probe a different distance in the solar system. But the beautiful thing is that, let's say you see this fast flash, and now you will require that this fast flash should not only be seen in 1 telescope, it should be seen in 2 telescopes, so that I don't have to have the same problem as we had with the old photographic plates and the 9 transients, where you never could really prove that they are real. Because if you see them in 2 plates, these flashes, if we would see the 9 transients in the 2 different, not 2 plates, but in 2 different telescopes, I don't think anyone would argue with us about that they are real. And that is what we want. Validation, a proof directly that these are authentic phenomena. Now, the beautiful thing is that you're also going to have a little offset if you have a spaceship moving in the solar system. And this little offset is in the image of the flash is going to allow you to calculate the distance to it. So, fantastic. The more telescopes you have, the more fun things you can do with it. In the first phase, we are imagining 3 observatories. So ignore this map. This is just showing how it potentially could look when we were imagining it over California. In reality, we concluded that New Mexico is probably a better place, and our first telescope is going to be installed in a few weeks in New Mexico, at the border with Arizona. And the second telescope we hope to rent at a distance of, there is a place, an observatory at 30 kilometers distance, and we hope to have the second observatory there. Then we also have a special telescope that allows us to get a spectrum of all the objects in a field. And that one is also already in place in New Mexico. So very soon we're going to have our first phase system. Now, there are some very fun things that people normally don't think about when they hear about UFOs. And that is, I'm going to argue for why we should stay outside the atmosphere. When you do the experiments inside the atmosphere, as some of the other groups are doing, you can end up with troubles of the sort of national security concerns, because you can find maybe a secret military experiment that nobody wants you to find. Let's say maybe there is some flying vehicle or something done inside the atmosphere. Well, those things also exist outside the atmosphere, but you want to minimize the troubles because you want to have an easy life and not getting someone knocking on your door. And that's a good reason to stay outside the atmosphere. So select the distance between the two telescopes very, very carefully and well. And of course, the problem is that even when you're outside the atmosphere at the low Earth orbit, at, let's say, you're going to find thousands of satellites. Starlink is not our friend. So these satellites are going to disturb a lot. Now you can go higher up, you can go to the geostationary orbits, and you're also going to find thousands of satellites, and you're going to find lots of space debris. So if you want to be a little bit smart and minimize the amount of work, because we should always try to minimize the amount of work to get clean results. What we can do then is to simply try to go even a little bit further, and even a little bit further out in the inner solar system, where we look for these alien probes. Because if you are, let's say, at distances beyond the moon, for example, you're going to know, if you find something that looks artificial, you can directly match it with known human objects. Let's say there are catalogs that tell you if a human object is there or not. Of course, I needed this label just because I've kind of found it fun. But we also have a method to filter away all kind of human satellites and space debris when we do the searches. And that is a fun little trick we came up with. And it's an entirely new method to do so. And this is part of our project because, again, we really want to minimize the number of false positives because we want our hypothesis test to be simple. And this is one more feature that we're going to do. That's step 4. So the Space Laser Awareness that I collaborate with, led by Dr. Geoff Marcy in California, has developed a very good method to obtain spectra. And the beautiful thing about it, what it allows us to do is to get a spectrum of of this flash immediately. Because if you have a 1-second flash, you don't want to come back 2 months later and say, what was on that place? Was there anything there? Because the flash is not going to be there. You're maybe not having a second opportunity. So you want to get this spectrum immediately. And that will allow you to, and with the help of the spectrum, you can see whether the flash is caused by reflection of sunlight on metal, or if you are actually having some very weird emission from something that is completely unknown and doesn't match anything known in astrophysics. That would be pretty cool. That would be your UAP. And this is what we want to be doing. For every flash, we want to immediately see what could be causing this flash. We hope We hope with time to have not only these 3 telescopes, but once we have been practicing and working with the large data flows, because we are going to get, for every telescope, one night will produce 3 terabytes of data. That is a lot of data. So now imagine we have solved this. Then we are going to want to increase the range of altitudes and how far and how deep out in the solar system we can search, and also how close we are willing to search. Because the closer we get, the more human objects we have. But the better methods we develop, we will be able to both go further out and closer to the Earth. Also, although always outside the atmosphere. And by doing that, we also have one more beautiful plus, and that is that it will be, the more telescopes you have, the better accuracy you can get on localizing an object in 3D. And that is, of course, very important, because we want to do one more thing. Why would we want to have such a good accuracy? Could anyone guess? Sorry? That's true. No, but we are a bit ambitious. We want to pick it up. Let's say you have an alien probe and you know precisely where it is. What would be cool is, of course, to somehow fetch it and bring it down to Earth to study it. And that would, of course, be our ultimate goal. And you know that we are capable to bring samples from asteroids. For example, in September 2023, OSIRIS-REx brought down a sample from an asteroid that was at a distance of 300 million kilometers. That means that if we find an alien object, we, in principle, could also go and fetch it and bring it down to Earth to study it. And I'm imagining that one can simply collaborate with the space garbage collecting companies and hope that they will collaborate with us too. So this project has about 40 members in all these results that I've been showing until now, all spread over 4 continents. And we have astronomers, machine learning scientists, and also civilians who are helping to teachers who are helping to organize the various parts of the project. And I'm going to leave you here with a final animation of how I'm imagining that when we see a flash from an alien object, how our exoprobe system with the multiple telescopes could search and detect these flashes. And I think I'm finishing here.